Temperature and atmosphere are the first essential factors for life on Earth. The blue planet has both a temperature that is inhabitable and an atmosphere that is breathable for living things. These two extremely different factors, however, have come into being as a result of conditions that turn out to be ideal for both. One of these is the distance between the Earth and the Sun. Earth could not be a home for life if it were as near the Sun as Venus is, or as far from it as Jupiter. When one considers the universe as a whole, coming across a range of temperatures as narrow as this is quite a difficult task. Because temperatures in the universe vary from the millions of degrees of the hottest stars to absolute zero, which corresponds to a temperature of -273 degrees Celsius. In such a vast range of temperatures, the thermal interval that allows life to exist is slim indeed. But our planet Earth has it. The American geologists Frank Press and Raymond Siver draw attention to the average temperatures prevailing on Earth. They note that life as we know it is possible over a very narrow temperature interval. This interval is perhaps 1 or 2% of the range between a temperature of absolute zero and the surface temperature of the Sun. The maintenance of this thermal range is also related to the amount of heat that the Sun radiates, as well as to the distance between the Earth and the Sun. According to calculations, a reduction of just 10% in the Sun's radiation energy would result in the Earth's surface being covered by layers of ice many meters thick, and if that were to increase by a little, all living things would be scorched and die. Not only must the average temperature be ideal, the available heat must also be distributed fairly equally over the whole planet. A number of special precautions have been taken to ensure that this in fact happens. The Earth's axis is tilted at an angle of 23 degrees 27 minutes in relation to the plane of the Earth's orbit around the Sun. This inclination prevents overheating of the atmosphere in the regions between the poles and the equator. If this inclination did not exist, the temperature gradient between the poles and equator would be much higher than it is, and the temperature zones would not be so temperate or so easy to live in. The rotational speed of Earth on its axis also helps keep the thermal distribution in balance. The Earth makes a complete rotation once every 24 hours, with the result that alternating periods of daylight and darkness are fairly short. Because they are short, the thermal gradient between the light and dark sides of the planet is quite modest. The importance of this can be seen in the extreme example of Mercury. As the rotational speed of Mercury on its axis is so slow, a day lasts longer than a year, and the difference between daytime and nighttime temperatures is almost 1,000 degrees centigrade. This terrible temperature difference would allow nothing to live. Geography also helps to distribute heat equally over the Earth. There is a difference of about 100 degrees centigrade between the polar and equatorial regions of Earth. If such a thermal gradient were to exist over a completely level area, the result would be winds reaching speeds as high as 1,000 kilometers an hour, sweeping away everything in their path. Instead, the Earth is full of geographical barriers that block the huge movements of air that such a thermal gradient would otherwise cause. These are chains of mountains. At the same time, there are a number of auto-control systems that help keep the atmospheric temperature in balance. For example, when a region heats up, the rate at which its water vaporizes increases, causing clouds to form. These clouds reflect more light back into space and make rain fall. This prevents both the air and the surface below from growing warmer.